Hi everybody, this is Joanne. Several videos back I determined the average weight of gummy bears, and then I was also working on trying to determine the average volume of a gummy bear by measuring 3 dimensions and calculating. That is not the best way to determine the volume of an object that's an irregular shape. There's a much better way to do that, so let's take a look at that now. Determine the volume of a gummy bear by measuring its dimensions and calculating it. That's not going to be very precise simply because gummy bears are not a regular rectangular cube shape. So the best way to determine the volume of an irregular shape is by what we call volume displacement. And basically you have a known volume of liquid, usually water, and whatever volume is displaced will be the volume of the object. So I'm dropping a gummy bear right now into this graduated cylinder filled up to 11 milliliters or centimeter cubed of water. And I can see that the volume has been displaced by 2 milliliters of water. Okay, so now that we know the volume of our gummy bear as being 2 centimeters cubed or 2 milliliters, and knowing that its average weight is 2.3 grams, we can use that information to calculate the density of a gummy bear. Now, this is easy. We just basically divide the weight by the volume. So that's 2.3
grams divided by 1.8 milliliters, giving us 1.28 grams per milliliter.
Otherwise known as the specific gravity of the gummy bear. Now, if we could create an amazing gradient of liquid in a tube that's very heavy liquid at the bottom and very light liquid at the top, and we know the densities of the different liquids in that column, we could also drop our gummy bear in there and get an idea, depending on where the gummy bear lands, what is the density of the gummy bear. And so we're going to do that here in just a minute with this density gradient column that I was reminded of how to make through Steve Spangler's new book, Naked Eggs and Flying Potatoes. This is one of those books that just has lots of fun science experiments that you can do at home. They are safe, they wow you, you can impress your friends, and you can learn more about science at the same time. The great thing about a density gradient column, this one of course is very colorful and amazing, but we use them in science. And as a biologist, sometimes maybe I just want to study the proteins that are only found in mitochondria, or maybe I only want to look at different proteins that are in the nucleus. Well, how am I going to break apart a lot of cells and collect only a very specific organelle? And there is a way to do that, and it is by using the densities. Each organelle has its own density and will fall in the liquid that shares that same density. So what we do is we take a test tube, and in the bottom we put a very heavy, dense liquid, and at the top is very light liquid, and then there's just different layers that's light, heavier, heavier, heaviest. And the organelles will fall and match that density. We can also do this if we wanted to separate out the 6 different types, because each blood cell matches a different density. So these have been very useful diagnostic and research tools. Also, if we've just created a new material and we wanted to discover its density, there's a way to do that by creating a density column. Like I said, those columns aren't as colorful and fun as this one, but let's go ahead and take a look and see where my gummy bear falls in this density column.
Here I'm pouring the densest substance to our column, which is honey, and honey has a specific gravity of 1.42 grams per centimeter cubed. The next substance is corn syrup, which I colored green, and this has a specific gravity of 1.33 grams per centimeter cubed. Here I'm adding dish soap, which is slightly denser than water, and you can see that I'm pouring it straight down the center of the column, not allowing it to touch the sides of the column. This has a specific gravity of 1.06 grams per centimeter cubed. The orange substance is water. Water is the baseline substance that we use to compare all other substances in the world to when it comes to specific gravity. It has a specific gravity of 1.00 grams per centimeter cubed. Here I'm using the pipette again To allow the liquid to flow down the side of the column, this is vegetable oil, and vegetable oil, as we know, floats on water and has a specific gravity of 0.92 grams per centimeter cubed. Recall that specific gravity and density are interchangeable terms. The purple substance here is a mixture of water and ethanol, and this is even lighter than oil with a specific gravity of 0.84 grams per centimeter cubed. Again, allow all the lighter substances to flow down the side of the cylinder that you've chosen to work with. I'm using 50 milliliters per substance here, but you can choose to make it more or less, whatever you have on hand. The final ingredient is paraffin oil, which is already colored red, that I bought from the store, and it has a specific gravity of 0.81 grams per centimeter cubed. As you can guess, our gummy bear is going to pretty much sink pretty far down into this density gradient column.
If you have a good eye, you might be able to see I already have one gummy bear that I tested in here, and it's fallen at the interface between the syrup and the honey, which doesn't surprise me because there is a lot of sugar in a gummy bear. I do know it's denser than water. Remember, water is a specific gravity of 1, and this gummy bear I calculated having a specific gravity of 1.15, although it could be higher depending on my measurement accuracy. So let's drop a gummy bear in, watch it come on down and see where it lands. Woo! And you can see how it slowed down at the sugar, at the corn syrup. And it'll take a while for it to settle where it belongs. All right, I'd like to thank you all for sitting here and learning a little bit more about density. And go ahead and make yourself a density gradient column at home and check the densities of several other items that you might have around the house.